Imagine looking into the night sky and discovering a star that behaves in a way no star should. Not slightly unusual, but suddenly losing more than 20% of its light with no predictable pattern before returning to normal as if nothing had happened. These patterns are usually so reliable that astronomers can detect planets hundreds of light years away simply by measuring tiny, predictable changes in a star's brightness. This method was the primary tool for NASA's Kepler space telescope, which spent years monitoring the cosmos for those exact subtle rhythms. But the data from a star called KIC 8462852 defied every model. Instead of a minor dip, the light was plummeting by enormous amounts at random intervals. There was no repeating orbit and no obvious explanation. A dip of 20% is impossible for any known planet to cause. Even a planet as large as Jupiter would only block about 1% of a star's light. This wasn't a standard transit. It was a massive void in our understanding of how stars work. Automated computer algorithms actually missed these signals because they were strictly programmed to search for the smooth, repeating orbits of traditional planets. It was human volunteers with the Planet Hunters project who spotted the erratic data, manually scanning Kepler's records and noticing drops that didn't fit the mathematical mold. Astronomer Tabetha Boyajian led the investigation to confirm these findings. Her team verified that this wasn't a telescope error or a data glitch. The star, now nicknamed Tabby star, was genuinely flickering. If no known planet can cast a shadow this large and irregular, we have to ask what else could be out there, orbiting a star 1,400 light-years away. Physicist Jason Wright suggested a hypothesis that, while speculative, fit the erratic data. An advanced civilization might be building something massive around the star. This idea connects to the Dyson Sphere, a concept proposed by physicist Freeman Dyson, involving a vast network of energy collectors designed to harvest a star's power. A vast swarm of satellites or solar panels wouldn't need a perfectly circular orbit. They could cross the star in clusters, creating the exact jagged, unpredictable light drops observed in the data. The media embraced the idea immediately. Headlines around the world suggested we might have finally found evidence of alien engineering. To find proof, the SETI Institute pointed powerful radio telescopes toward Tabby star, searching for narrow-band transmissions that would confirm the presence of technology. The result was total silence. Without any confirmed radio signals or unmistakable evidence of life, the alien hypothesis remained unsupported, forcing scientists to look for a natural suspect. One natural possibility involved a massive swarm of giant comets passing in front of the star and casting irregular shadows. But the number of comets required to block 20% of a star's light is extraordinarily large. Mathematically, it is a difficult scenario to sustain. Researchers began looking at other candidates, such as fragments from shattered planets or dense clouds of cosmic dust. Cosmic dust leaves a specific signature because it blocks different colors of light at different rates. By measuring these variations, astronomers can distinguish dust from a solid object. When scientists looked at the multi-wavelength data for Tabby star, the measurements matched what dust would produce. Cosmic space dirt is now the leading scientific explanation. A cloud of dust might seem like a disappointing conclusion compared to an alien civilization, but the investigation itself was not a failure. Science advances by investigating anomalies rather than ignoring them. Every major discovery begins with someone noticing a data point that refuses to fit. History shows this pattern repeatedly. Pulsars were once jokingly nicknamed little green men, before we realized they were actually a previously unknown class of rotating neutron stars. Tabby star represents a natural phenomenon that hasn't yet been fully cataloged. It serves as a reminder that we only learn more about the universe when the data refuses to match our expectations. This star demonstrates how science actually works, through curiosity, observation, and the willingness to change our minds when new evidence appears. A moment of wonder. Somewhere in the vastness of the cosmos, another mysterious star is already shining, waiting to be found.